Acephysics.org, Math and Physics Tutoring with Dr. Hudis.
Hello, it's January 14th, the year is 2016, and I decided to make a video called A Day in the Life of a Physics PhD Student. I'm in my second year. If I were to make this in the first year, it would probably be just a video of me sitting at a desk doing homework and cursing my life, but the second year is a little bit better. It's a little bit calmer. Right now, I'm in my living room. I got all the lights on. It's 1:43 in the morning. Maybe you can see from the clock. I have to go to school because we're running an experiment. It's a Hall measurement. I need to change the magnetic field. I'm not going to get into the details of that. I can talk about that later. And I decided to make the video today because one is it's something I've been thinking about making for a couple of months now. And tomorrow I have 2 classes and there's an experiment going, so it's a pretty eventful day, and I thought that'd be a good time to do it. Tomorrow is today, I guess I should say, so I'm going to go to school and change the magnetic field, come home, sleep for a few hours, and get up at 7 for class, and so let's see how it goes. I hope you enjoy coming along with me and seeing what my day is like. So it's currently 1:40 in the morning. I'm heading over to school.
Sloshing motion of the water.
I'm driving to school right now.
And the sand.
So I have the Feynman lectures on physics. I'm listening to them in the background. I like to listen to them when I drive. 2:05. I'm going to change the magnetic field at school now. Physics building. I don't know if you can see anything. There's a dorm. It's very dark. Too many keys. It's good. Temperature 478 millikelvin. Oh, son of a... I have a while to wait here. Darn it. Darn it. So, I was told to come here at 2 o'clock, and the magnetic field right now is only at -6 Tesla. And I need to wait for it to get to be -8 Tesla, so I'm basically pissed off. Alright, it's the morning. I got about 3.5 hours of sleep last night. Surprisingly, I'm not as tired as I was expecting I would be. And I'm going to continue with this video I'm making about the day in the life of a physics graduate student. I'm off to class. Right now it is 7:21 in the morning. I woke up 21 minutes ago, brushed my teeth, put on my clothes. I didn't have time to eat anything. I gotta go to school because I have an 8 o'clock class. I'm probably going to be a few minutes late the way things are going right now. A day in the life of a physics PhD student. Walking in my car. It's chilly out this morning. I don't know what temperature it is, but it's definitely cold. There's a ton of traffic on the road, which is pretty typical at this time in the morning, Tallahassee. And I'm a little worried that I'm not going to be able to find parking once I get to school. Class in 10 minutes. Alright, it is now 7:59. Class will start in 1 minute, and I will surely be late. Parking. I have 1 minute to get to class.
On the right hand side, on the n-type side, the chemical potential is actually near the conduction band edge. Or here, the chemical potential is near the valence band edge. Well, that's obviously a out of equilibrium situation. So electrons here have higher chemical potential than electrons on the other side. Or electrons on the n side, thank you very much, has a higher chemical potential than electrons on the p side. Well, that's a non-equilibrium situation. So electrons will move. The electrons will move. Well, if you remember, just like that, from high chemical potential side to the low chemical potential side. So electrons will move from the right hand side to the left hand side, which is actually not surprising. Here you have more electrons here than here. Okay, so we know that the Laplacian of electric potential phi, in this case, because things only depend on x, and we assume that we have infinitely large junction, so things are translationally variant in the YZ plane. So that's nothing but the second derivative squared phi of x. Okay. So this is equal to minus 4 pi rho of x, and we need to divide that by epsilon, which is a dielectric constant. So here rho, let's be careful, is corresponding to the mobile charge that coming from either the electron in the conduction band or the holes in the valence band, or this epsilon, the dielectric constant really comes from the response of the core electrons or the ions, which are also polarized. Okay? So one can actually try to solve this equation. Of course, you need to have additional input because we don't know phi and we don't know the rho. So this is just one equation. But at least we can actually use this global constraint to actually get some qualitative behavioral properties.
Hello, I'm Dr. Jacob Hudis. If you need math or physics tutoring, please go to my website, acephysics.org, and book a lesson.
All right, well now it is 9:18 a.m. and I'm back, well I'm not back, I'm in my office right now, and I'm about to go to Starbucks and get a coffee, and then I'm going to go to the gym and have a workout. I'm starting to get a little bit tired, but I have a long day ahead of me and I'm not exhausted, I'm just a little bit tired. I might have some bags under my eyes, I'm not sure how I look. And a little tour of my office. I share this with two other people. And little view overlooking a dorm in the street. There's a lot of construction. A lot of construction going on at FSU right now. Starbucks coffee with a shot of espresso added in. Now it's time to go to the gym. Alright, I just finished my workout. I had a great workout today. I was killing it in the gym. And now I'm going back to my office. I have a class in about 2 hours. Let's see what time it is right now. Right now it is 11:41 a.m. Headed back to my office. So I'm heading back to the physics building now. Alright, I'm going to go see if I have any mail in my school mailbox. Looks like I do. Course evaluations.
Alpha also, but I've already done some on mu. And similarly here, I'm left with this beta. And so drawing this picture, we just have 1 minus 1/2, just using these rules. There's, okay, the minus 1/2 is this, and then we have a state sum over all possible states you can sum over, in this case alpha and beta. Alpha, beta, v, and we've, alpha is, mu is alpha and nu is beta. And we have an integral from 0 to beta, and then we have the Green's function, g alpha, but since we go from time tau to an end at time tau, it's g alpha of 0, g beta of 0. Anytime you have a closed loop like that, it's just going to be the Green's function evaluated at time tau equals 0. And we know that this is equal to, well, actually we know the whole, we can do the integral on tau, because the integrand is constant. And we know g is zeta times n alpha, zeta times the usual Bose-Einstein occupation number, or so what should go here? Alpha, and what goes here? Beta. Really?
No, those are the things that are leaving the vertex, right?
Delta.
Delta.
Right. These are the states,
Right.
if you like, in a typical matrix element, this is the outgoing states. These are the incoming states. So the arrows coming out of this is alpha and delta. And beta and gamma. Tau 1 minus tau 2. And here I guess I do have to go over the line. G delta, tau 2 minus tau 1. So this diagram, you can think of this diagram as something that should be evaluated. Associated with this diagram is a number. That number is given by this. Minus tau. Right?
Yes.
Now, this part here, even though it's K2, K1, I can call this shit.
It doesn't matter because they're both the same, right?
I can call this K2.
All right, right now it is 3:35 in the afternoon. I just got out of class, second class of the day, and I'm heading over to the dilution refrigerator lab to do a resistance versus temperature measurement.
AcePhysics.org. Math and physics tutoring with Dr. Hudis.
Junction resistance. See how that goes. This is liquid nitrogen. All right, so the pressure is going up, lowering the temperature. You can see that the temperature is dropping. And I'm going to wait till the temperature so the pressure gets to 175. Okay, so right now it is 5:45 p.m. I was working in the lab. I just finished some R versus T measurements and resistance versus temperature. Now I'm going to go get dinner, and then I got to come back and do a helium transfer at 8 o'clock tonight. Now I need to get a helium doer because we have to do a helium transfer. All right, this is the helium recovery, $500,000 helium recovery system. And then you get the helium doer. I finally made it home. It's 9:30. On the way home, I got a fruit smoothie at Smoothie King, and I talked to my mom in the car for about 30 minutes. I parked and talked to her for about 30 minutes, asked her how her day was, and we discussed politics and news, and then she fell asleep. And now I'm going to take a shower and shave, and then I'll go to sleep. Tomorrow I don't have any classes, but I have to go and continue working on the experiment, and I have homework that I'll be working on most of the day. And it's Friday, TGIF, although I have to work on the experiment again on Saturday and Sunday. Hopefully we'll finish the experiment this week. And thanks for spending the day with me. I hope you enjoyed it, and have a good night, or a good morning, or a good afternoon. I guess it depends on when you watch this video.